What if some of the most important scientific discoveries in the ocean did not come from looking for answers, but from noticing something unexpected? An instrument suddenly goes silent. A camera captures life moving faster than anyone thought possible. A platform designed to sit still tumbles down to the seafloor and opens up a decade of new science. These are not accidents. These are moments where curiosity meets technology, and where long-term ocean observing reveals stories we could never tell before. We're going to talk about scientific discoveries on this episode of the How to Protect the Ocean podcast. Let's start the show. Hey everybody, welcome back to another exciting episode of the How to Protect the Ocean podcast. I'm your host, Andrew Lewin, and this is the podcast where you find out what's happening with the ocean, how you can speak up for the ocean, and what you can do to live for a better ocean by taking action. And this episode is part of Surfacing Secrets, Explore the Planet and Know the Ocean. It's a special series created with Ocean Networks Canada that takes you beneath the surface of the ocean to uncover how science, technology, and curiosity come together to change what we know about our planet. Over the past few episodes, we explored origins of Ocean Networks Canada, its partnerships, and the people behind one of the most advanced ocean observing systems in the world. Today, we're focusing on one of my favorite topics, which is scientific discoveries. We are talking about the moments when data reveals something not one expected, when instruments capture events that last only seconds, and when years of patience suddenly pay off with a breakthrough that reshapes our understanding of the ocean. Joining me today are Richard Dewey, former science director at Ocean Networks Canada and one of the original architects of the network, Kohen Bauer, who is the science director at ONC currently, and Gwen Lintern from Natural Resources Canada, whose work on the Fraser Delta has led to the world's first discoveries in submarine landslides and sediment dynamics. Together, we will explore how real-time ocean monitoring unlocks discovery, why sound has become one of the most powerful tools in understanding the deep sea, and what these discoveries mean for ocean health, coastal communities, and our relationship with the ocean itself. This is a conversation about curiosity, patience, and what happens when we listen closely to the ocean. So here's the interview with Richard, Kohen, and Gwen talking about ONC scientific discoveries. Enjoy, and I'll talk to you after. Hey, Richard. Hey, Kohen. Hey, Gwen. Welcome to the How to Protect the Ocean podcast. Are you ready to talk about scientific discoveries with the ONC, with Ocean Networks Canada?
Ready to go.
Big time.
Right on. Love it. All right. This is going to be great because, we've had this ongoing, monthly podcast with Ocean Networks Canada. And it's been a lot of fun to sort of discover the art that goes on, the Indigenous partnerships that ONC has and has been working, on those relationships and continuing to grow those relationships and into some successful programs and education as well. And today we're talking about some of my favorite things as well is scientific discoveries, some things that we've discovered, some of the things that have come out of all this data that has come up from the bottom of the sea, which is a lot of fun. So we have some experts here who've been working alongside or with Ocean Networks Canada for a long time. So it's going to be great. I can't wait to get started. So let's get started. Before we get into the scientific discoveries, let's give just a brief intro. So just who you are and what you do within this whole this whole thing of Ocean Networks Canada. What we'll do, Richard, we'll start with you. Why don't you just let us know your name and your title?
Yeah, Richard Dewey. Just retired, but I was the prior science director with Ocean Networks Canada. And I was one of the original authors on getting the whole system going, writing the first proposal back in 2001. And I was with Ocean Networks Canada for about 22 years. So long time standing as an oceanographer, leading the science team at Ocean Networks Canada.
Fantastic. And Kohen, how about yourself?
Yeah, hello. I'm excited to be here. My name's Kohen Bauer, and I currently serve as the Ocean Networks Canada Director of Science. My background is in marine biogeochemistry broadly, and so I like to think about marine biogeochemical cycles in past, present, and future scenarios. And here at Ocean Networks Canada, as one of the leads of the science team, our role really is to unlock that scientific discovery using all the amazing tools that Ocean Networks Canada provides, the data and also the physical infrastructure.
And Gwyn, how about yourself?
Hi, Andrew. I'm Gwen Lintern. I'm a research scientist at Natural Resources Canada, and specifically a part of that called the Geological Survey of Canada Marine Section. And we look at natural hazards. We look at all sorts of processes on the seabed. And I was lucky enough to be introduced to Ocean Networks Canada by my former manager, Phil Hill, who put me in charge of leading, I guess, one of their sort of major projects from the beginning, which was to understand all the processes on the Fraser Delta. And so I was running that for 16 years, and it's just been pulled out a year ago.
Fantastic. Love it. Love it. Okay, let's get into the whole thing. Richard, since you're retired, do you remember, as you've been part of ONC for many years, do you remember what initially drew you to ocean science, and then what has actually kept all that curiosity alive throughout your career, and has it continued through your retirement?
Yeah, thanks, Andrew. It goes a long way back. I grew up in Victoria, and my family sailed on the Salish Sea all the time. We went cruising in the summertime. We raced in the winter, and so I sort of grew up very familiar with being on the water. And I did my undergraduate at the University of Victoria in physics, and I knew I wanted to go into research, but I really didn't know what field. And in my last year at UVic, I had a professor who was an oceanographer, and he said, "Well, why don't you go into oceanography?" And at that very moment, all the lights went green. Everything just clicked. That, oh man, I could study the ocean. I could do something quite relevant. It was very practical. It's socially important, and I would probably in my career live near the ocean and be still able to participate in activities and recreational things on the ocean. So that's what I did. I went into oceanography, and I managed to come back to UVic in the early 1990s and started working in this area. And I've spent almost my entire career working primarily on coastal flows in the Salish Sea. So it's been a lifetime dream to be in oceanography, and it's a very privileged sort of existence because you get to study, or many scientists get to study what they're most interested in, and studying the ocean is very relevant to everything we do around here.
That's amazing. I mean, you've had a long career, especially with ONC. Can you remember a time where you were just like, this is really incredible, like a discovery, something that you saw where you're just like, this epitomizes what I've been wanting to do?
I think the biggest impact, or the most amazing thing working with Ocean Networks Canada, was the fact that we were building something with the science community. And it's a big network of researchers. And we were enabling new things that they wanted to do. And it was our job to go away, take their ideas, build a system, install it in the ocean, get it working, and then work with them to get scientific discoveries. And this network of researchers, we're talking about hundreds of researchers doing many, many different things. And I think it continues to be one of the most exciting aspects of Ocean Networks Canada. We're making such a big difference to so many researchers across all range of marine science. So I think that was unanticipated and most rewarding.
Amazing. Now, Kohen, looking at the way ONC monitors data, it really has changed the game in terms of the amount of data that comes in, and what we can really understand about the ocean. Can you describe a moment where having that real-time data led to something surprising that or unexpected?
Yeah, absolutely. It's a lot, right? We live the network, the ONC network by definition is very data rich, right? So
Yeah.
we are making measurements every second across a diversity of ocean environments, and so it can be a challenge to really keep up to date and monitor all those streams that are happening in real time. Um, so there comes with an intentionality, right? And so when we have a hypothesis or a scientific question, it's important to follow up on that. And I'll give you an example. And so um, we deployed what's called a benthic lander in the deep ocean, and this contains some organic substrates, one of them being seaweed. And we really didn't know what would happen to this seaweed in real time as it resided in the deep ocean in the oxygen minimum zone. And so we would just watch the camera feed, which is what the experiment was about. And sure enough, just by watching this camera every day, different deep sea organisms visited the site and completely consumed this seaweed on very rapid timescales. And this was really surprising and one of the first experiments that we're aware of that actually observed this in high resolution. And so this type of experiment would not have been possible without the tools and the network that ONC provides. And so it feels pretty cool to be involved in really leading edge science like that.
Yeah, it's incredible. I mean, with so many instruments in the water, how do you decide what data to look at? Like, how do you prioritize that? Are you always like, where do you search? What are you looking for when you look for something new? How does that all get disseminated from a science perspective at Ocean Networks Canada?
I'll start, and then I think Richard's one. I mean,
Yeah,
we have
absolutely.
an amazing team at Ocean Networks Canada that goes beyond the science team, right? We have data specialists that, one of their primary roles is to really monitor our data streams and to ensure that those data streams are of high quality. And so that, I think, is the first pass on just ensuring that we don't have any issues with instrumentations and that we are collecting data that can be robust and interpretable. And then really, like, the data that we collect is not for ONC, it's for everybody else. We want
Hmm.
everybody else to make use of this data and to come up and create knowledge. And so really then it's engaging with the scientific community to ask questions and interpret that wealth of data.
Yeah, and
Richard?
I would follow on that was we rely on that research community as well to help us monitor all these channels.
Hmm.
Very often we've installed a system with a particular subgroup of researchers that's their area of interest. So they may be monitoring those signals more closely than we're able to because we've got hundreds and hundreds of channels.
Hmm.
And very often they'll contact us and say, "Oh, did you guys see this phenomenon that happened? Or did you see that in the camera feed?" And it's we then go have a look at it. We may have known that there was something happening, but then sure enough, we look at that particular section of data, and something new has come about. So we do rely on our research community as well to help us monitor all of these channels.
Hmm.
Amazing. And it's interesting when we talk about all these things that you can monitor. One thing that comes to mind is, when you and I discussed, we discussed the Delta Dynamics Laboratory. Can you just talk about one, like, how important that discovery was, and how the whole lab kind of came together?
Sure. Yeah. I'll back up a
Yeah,
little
please.
bit. The we specifically wanted to be looking at submarine landslides, and these are events that occur just they could take a few seconds, and they may occur just every few months or every years, or and so that was the power of a live observatory, is that we could monitor for years and capture these events that take just seconds, and nothing else could have allowed us to do that sort of work. And as far as the monitoring the number of instruments and how to prioritize those, we went to Ocean Networks Canada with an experiment in mind, saying we'd like to use your network to look at these events, delta events and submarine landslide events. And so in that case, we were able to kind of specify which instruments exactly, and even yet, there's still what we call a fire hose of data coming at us
Yeah.
on these. We have something like 14 instruments spitting out data at millisecond intervals, and all year round. And so there is a fire hose, and so we kind of prioritize what we're going to look at. And there's a lot of data that we won't look at now, but that we'll pass on to other scientists and other generations even. So the Delta Dynamics Lab came about as a proposal right at the beginning from my former manager, scientist Phil Hill, who wanted to look at all the delta processes that were taking place on the slope of the Fraser Delta, an important river coming out of Vancouver near the airport. And there were sort of two main platforms. One was a delta platform measuring sort of oceanographic properties, and the second was one that would penetrate into the seabed to measure slope properties, slope stability properties, and that sort of thing. The first one, the one that was meant to be measuring water properties, at one point it was picked up. Suddenly we lost data transmission to it, And in looking at the data afterwards, we determined that actually it had tumbled down the slope from a from an avalanche, which was one of the processes we were looking at, but that wasn't the instrument that was designed to do that. So anyway, that was sort of the start of
a little bit of a surprise.
Yeah, it was the start of another 10 years of research, specifically on that we sort of opened up to the world, and we became sort of the lead researchers in the world in that specific topic of submarine landslides.
And so that was obviously an unexpected event. It led you to a decade of studying and information. But what did that teach you about the forces at play in those delta environments, like the Fraser River?
Yeah, there were a few sort of new things in this. I mean, these type of underwater avalanches, let's call them, but they're actually called turbidity currents. They're a mass of sediment and water that flow hundreds of kilometers off coastlines and can damage cables and pipelines and that sort of thing. They were known in the world, but they were hardly measured at all. And so we now had this platform that was basically in the path of these, and we were able to measure the properties of them, but also the frequencies, what they look like, the power structures, and these sorts of things. And so it really did. Also, in this case, these were known to occur in submarine canyons, and they were canyons. That's how canyons are formed, often with these kind of repeated avalanches running through them. But in this case, this platform was actually on the outside of a canyon, on just on bare slope of a delta, and so that was new to science, to be measuring these things on just an open slope like that. And now that we can know that they occur here, we've actually started to be able to predict them based on tides and how the rivers, how much sediment is coming out of the river and that sort of thing. And we can sort of go from almost having no measurements in the world to now practically predicting them, just in that 10 years of research on the network.
I remember when, I guess a little anecdotal story there. I remember when Phil and Gwyn came to us as the builders and operators as ONC of the observatory, and they explained this experiment to us. And they said, what we'd like to put these instruments down on the slope and measure data for a few years, and then we're just hoping that a landslide comes and takes them all out. And it was a bit of a shock to us, because here we were investing all this effort and money, and one of the things we tried to do is make sure these instruments aren't lost and don't get carried away, and they stay there and say. And this whole experiment was an attempt to say, no, we want a disaster to happen, and sure enough, it did several times.
Yeah, I would just say it's kind of like a beautiful closing the loop here, in that Gwyn and Richard are mentioning that this work had been carried out for over a decade, and I'm the newest person to ONC on this call, right? And so I came in, and I wasn't involved in the inception of this experiment, but I was on the ship when the experiment was recovered last year. So kind of bookending this, and then being described all the discoveries that came out of this work, and then seeing this platform come out of the ocean in real time was like a really special experience, right? And just being connected to experiments that I wasn't involved in directly, but it's so informative and a great learning experience. So I felt really lucky to be there.
Yeah, I can imagine. And Gwen, take me through that part where you retrieve the instrumentation after losing it, and then you're going through the data. What is your reaction when you realize when it happened and what had happened? What goes through your mind when you see that?
The eureka moment.
Yeah.
Yeah. So it's a little bit of a slow process. So this took years to get to this point, building the platforms, getting them down, and then of course we lose the signal from this large major installation on Ocean Networks Canada. We lose the signal, and all of the engineers and the managers and all the people, as Richard said, are are concerned. What's happened? And so they're looking into what's happened. How are we going to get this back? And that sort of thing. And as scientists, we're sort of looking at each other thinking, could this be? Could this be it? And
yeah.
And so we spent a few days going through all of the last few seconds of data, and eventually, you just, I think that the main one, it's all tangled because the instrument was tumbling, but once we saw that the instrument had tumbled, you could see that clearly in the pressure data that the instrument was tumbling down the slope. And once we put it all together, you sort of, I guess, you ask what it's like, you kind of, at that point, you sort of lean back in your chair and clap your hands together and say, this is it. This is what we had some idea that this could occur on the Fraser Delta. We had seen sand waves before that indicate that sediment's moving in a single direction, just like sand dunes on land. And we'd sort of seen evidence that these could occur, and so it was. It's kind of a big moment in your career to be working towards something and then be able to just say that is it. We have irrefutable proof.
Yeah, I can imagine. This is great, and I'm sure we could do an entire episode on the Delta Dynamics Laboratory. But we're going to switch over to a little bit, Richard. I want to talk about acoustic sound and the acoustic instrumentation that ONC uses. Now, from my perspective, like in my work that I've done, I've done some work with acoustics when we look at tracking marine mammals and so forth, around oil and gas installations and things like that. But for ONC, like, what are some of the I guess the most memorable or mysterious sounds that ONC has recorded on the seafloor? Because this is something that I don't think people realize, that the sounds that are coming from the seafloor.
Right. Well, we have the hydrophones, these are underwater microphones, basically.
Yeah.
And they're extremely sensitive, and they can measure the faintest sounds. And so they're seeing a horizon, if you like, that is very large. They can hear things that may be kilometers away. And in the coastal waters, like the Strait of Georgia, we sort of have the background din of almost continuous ferry traffic and freighter traffic. And superimposed on that, occasionally we get the orca whale vocalization. So that's pretty exciting, like you're talking about, when we're hearing marine mammals. And then offshore, we have hydrophones at places like the Endeavour Ridge, where there's earthquakes and other things happening. There's vents, hot vents, black smokers, and you can actually hear with sort of a venting sound, and you can hear earthquakes. We often have earthquake sensors that are really feeling the movement of the earth, but earthquakes also generate sound. And it turns out at these places, this ridge in particular, is very active, and there are hundreds of earthquakes a year. And so our hydrophones are picking up earthquake sounds, grumbling and venting on a continuous basis. So one thing, again, coming back to sort of this idea of what was surprising, is that how continuous sounds are throughout the ocean, whether you're in coastal waters or even deep in the ocean. There's a lot of sound, and it's pervasive, and it's there all the time. And it's not quiet. I mean, we often, most people that coming at this from going way back, again, look at the ocean and go, oh, I see the ocean and it's just this flat surface.
Yeah.
And then, if you're a scuba diver, there's a lot more happening underneath the water. Absolutely. And this was sort of, this is what we've been able to do is open up this mystery of what's happening deep in the ocean. And it's a very dynamic environment, and sound propagates a long way. So we're hearing things from maybe kilometers away, and it's very, I wouldn't say it's noisy, but right. There's sound almost all the time from all these different processes.
How does listening to listening to like ocean changes, like earthquakes and things like that, how does that help us, understand what's happening in the places we can't see? Like, how does that help us for overall science and overall understanding of the ocean?
It's telling us how dynamic the ocean is. I mean, if we don't have those indicators, we might think it's a flat ocean on the top. We can't see what's happening down below. Nothing's happening. But the sound and our sensors are really telling us, and the platforms we put down, like the Delta site, but we have these platforms across the network, are telling us that there are variations in things happening all the time.
Hmm.
And the sound gives us a big horizon. We can see again, maybe, or hear kilometers away. All these other sensors are measuring, cameras, for example, are measuring the local processes. But almost everywhere we put down the sensors, things are happening all the time. And that's, again, the power of the observatory. We're not putting something down and turning the lights on or turning the instruments on once a week. It's continuous. We're listening to it 24/7, 52 weeks a year for 20 years. And what you realize is that the ocean is incredibly dynamic all the time, everywhere.
Yeah, go ahead, Gwen.
I'd like to give a specific example of what Richard's talking about, the aerial extent of sound, because we're measuring these landslides, but you kind of have to be right on them to measure them, and they put your instruments at risk. And so our partners around the world have been putting instruments in canyons on the request of oil companies or cable companies, to determine how frequently these type of turbidity currents is what they're called, these underwater landslides, how frequently they occur and how large they are. And so we that basically almost every time the instruments get wiped out and tumble down the slope, and it's hard, and it's often you don't even get the data back because it wasn't cabled transmitting live. And so we've started using hydrophones now to measure the sound of the landslides near them or even at a distance, and starting to get records of, okay, now we can put these kind of out of the way and safely measure the sounds of landslides, not only on these sediment slopes like we were talking about earlier, but in areas like the fjords of British Columbia. So we've deployed hydrophones there too, or ONC have hydrophones on in various places in the fjords of British Columbia, and we've used them for listening for rock slides dropping into the ocean, which could cause major tsunamis as well. So we're using them as a kind of regional assessment tool to determine how large landslides are, how frequently they occur, and whether they could be used as an early warning to tsunamis.
Amazing.
Sometimes you pick up things that you weren't expecting. Like we had the first hydrophone was in Saanich Inlet, and it turns out it's near an airport, and we could hear planes flying overhead, and we could, in particular, if there was a seaplane taking off or landing, you could hear the seaplane.
And how far down was this hydrophone that you can hear?
About 100 meters down, and you hear the seaplane start up, and as we've seen a seaplane take off, it ramps up and then leaves the water, so the sound changes as it goes into the air. The other hydrophone that I think was really quite fun to listen to was one we installed in Cambridge Bay up in the Arctic, in the Canadian Arctic. And at this site, it gets frozen over in the winter.
Right.
And we anticipated that we might hear some ice cracking, and that was sort of really scary to hear. You wonder, because it's a sort of a real violent cracking sound as the ice cracks. But then also, as the ice got thicker, the community started to drive on the ice, both in cars and in snowmobiles. And so the pervasive sound later in the winter was all the community driving on top of the ice in their snowmobiles and cars. So we had not anticipated that, and that gave us sort of a window into the community going out on the ice and using the ice as a highway.
I love that. I think that's awesome. Richard, when we talked earlier, you mentioned, the Salish Sea, which is, the Promised Sea that's around there, is remarkably healthy. What are those key oceanographic features that make it so healthy? Because when we think about oceans, a lot of them we think that they're in dire need. And what makes Salish Sea so special that it could be so resilient?
Well, there are a lot of places in the ocean that we should be concerned about. And one of the processes that leads to this is when ocean water gets stagnant and doesn't renew. You can consume all the nutrients and maybe through respiration consume all the oxygen. And so water that isn't renewed can become sort of, we call them dead zones in the ocean. But it turns out with the Salish Sea, we have two large inputs of water. We have rain in the winter, so all the coastal rivers discharge a lot of fresh water. And in the summer, in May and June, we have the Fraser River discharging a lot of the snowmelt from in the interior of British Columbia. And all this fresh water has to eventually make its way out into the Pacific Ocean. If it didn't, then the Salish Sea would become fresh eventually. And it's so in its migration out to the Pacific Ocean, we also have strong tides. And the combination of these two processes, the estuarine circulation and the strong tides, gives rise to a very large exchange with the Pacific Ocean. We have a large volume of water flowing out of the surface and an almost equally large volume of water flowing in at depth in Juan de Fuca Strait, deep at the bottom. And this water that's coming into the Salish Sea in large volumes is full of nutrients. And the tidal mixing brings down oxygen and aerates the water. And as a result, these inner basins, like the Strait of Georgia, have a continuous supply of nutrients and get reoxygenated on a regular basis. And so for many inland seas, if the water's stagnant and sort of doesn't exchange, it becomes really sort of a dead and lifeless environment. But the Salish Sea has this wonderful combination of a large estuarine circulation and strong tides, which results in a very active exchange with the Pacific Ocean, brings in nutrients, aerates the water, and so we have lots of nutrients and lots of oxygen, which is just what a good habitat would need to be healthy.
And has ONC contributed to that information in terms of knowing all this stuff coming in and out?
Absolutely. There's a researcher in particular, Rich Pavlovich at the University of British Columbia, who's been with us for a very long time. He's been originally designing the system, and he's worked up a majority of the data for the Strait of Georgia that has really captured and quantified this deep water renewal and the deep water exchange processes. And he's got about a half a dozen publications that are really showing the enlightenment of this and demonstrate how the observatory has contributed to our understanding of this key process.
Fantastic. Kohen, for the Salish Sea, like looking forward, and what is what are the opportunities for ONC to really help have an even better understanding of the Salish Sea and its future to keep it a healthy sea?
Yeah, it's a great question. Recently, just this past summer, ONC convened a diverse community of researchers, NGOs, government organizations, coastal communities at ONC to talk about the future of the ONC observing system in this context of the Salish Sea. And so it was a really enlightening workshop with a lot of contributions from our diverse community, and it was exactly asking that question. How does the ONC facility evolve and continue to contribute the observations and tools needed to ensure that the Salish Sea remains a healthy ecosystem? One of the interesting things that came up in that discussion is when you have this wealth of data, how do you operationalize it to learn something or to, for lack of a better way of saying it, manage the Salish Sea so that, again, it remains, it can be stewarded and protected. And this concept of a digital twin came up. And so this is, a frontier sort of space in the big data and modeling world. And a digital twin is a model of a natural environment, or it could be a model of many models. And so what you need to make an accurate model is robust data, observations that tell you how the ocean environment is behaving and how these processes are interacting. And so one way I think that ONC could intersect with this sort of predictive modeling or digital twin style model of this region, of this urban seaway, is to just ensure that we have the right observations in the right places, and those observations and that data is of high quality. So, us being an infrastructure provider, it's really connecting with the community to ensure that we have the right tools in the right places, right? At the Fraser River Delta, in the urban seaways of the Vancouver ports, for example, in Saanich Inlet, right? Where should these tools be and what should they be comprised of so that we can continue to provide the data well into the future that people in the Salish Sea will rely on?
Yeah, Amazing. And I think also too, when you think about not just from a local aspect, but also from an international aspect, a number of years ago, there was this phenomenon in the Pacific called the blob. And it came down and it heated up the Pacific Ocean. And we were in an El Nino year. So it just sort of exacerbated the fact that there was such a heat bloom sort of in the ocean. Now, I remember, Richard, you and I were talking, I believe, and it didn't, like, the instruments didn't pick up the blob fully, but it did have some footprint in the data of this blob. What have you learned from like these big events, where you could capture a little bit of it, and what have you learned? Because if you have all these data acquisition instruments in the water and you can capture some part of this event, what did that help you teach and help ONC kind of learn from these events?
Yeah, that was a major event, and the blob we're talking about, the marine heat wave that started in 2013 to 14, was really far out to sea. It was at the surface layer of the ocean in the Gulf of Alaska. The entire Northeast Pacific was very, very warm that spring of 2014. And it wasn't until about a year later that water started coming near shore that our sensors picked it up. And so it was kind of exciting to see as this blob evolved from an offshore event to a coastal phenomenon. It raised the temperature of the coastal waters, in particular along Vancouver Island and into the Salish Sea, by about 2 degrees for 2 or 3 years. And it stuck around for a very long time. And again, this was not at all anticipated. We were familiar with marine heat waves. They seem to be becoming more frequent with climate change, but their persistence that it lasted offshore for over a year and then inshore for another 2 to 3 years. So the heat wave that was called the blob had such a large temporal and physical footprint that it was really quite remarkable. It's probably the largest marine heat wave ever recorded, and our data was contributing to its understanding when it came ashore. And it lasted for 3 years. It elevated the temperatures in the Salish Sea. We had, in fact, there's sort of an annual cycle. This is one of the things that the observatory picks up. It picks up all the variations, including annual cycles. And when the blob was along in the Salish Sea, the coldest temperatures we were seeing those 2 years, like the 2016 and 2017, the coldest temperatures were warmer than the warmest temperatures in some prior years. So the whole system had shifted up by 2 or 3 degrees, which was not anticipated.
No.
And the data, this long record, really helped us put it into context.
Absolutely. It's amazing too, because as a scientist, you see these events happen and you're always like, oh man, I wish I had some instruments in the water to detect that.
Right.
Here you have this long-term data set that's, been going on for decades, and you had it, and you're like, oh, we already have it. Here you go. And it's free. Like, we're going to push it on to whoever wants it and whoever wants to do studies on it. And I think it's so valuable in the scientific community these days, because so many times we're just like, I wish I had, the data for that, or it would have been really cool to monitor that. That is such an important part. And to also like transfer it to things that like you don't expect, with these discoveries, right? There was a story that came out, and I have to ask, I don't know who it was, but I need to know more about measuring this solar flare, or the interference from a solar flare. Can someone maybe talk about it, where you could actually measure it, and a solar flare of all things, like in oceanographic data?
It connects nicely to one of your earlier questions, and like how do you observe anomalies or special things that are happening in our data, and this is an example of a data specialist at ONC who's the person that recognized this. His name's Alex. So he was monitoring a bunch of streams of sensor data, and he recognized that there was something weird happening in this data, and all of this in particular in the compasses. So there's a particular instrument that we have in many different locations on our network called an ADCP.
Yep.
And as part of this instrument, there's a compass sensor as part of it. And the compass readings were behaving strangely all at the same time. And so then Alex contacted a few other people at ONC and is like, what could be going on here? His initial hypothesis that it could have been an earthquake.
Right.
But then in reading more into it, it just happened to coincide with a major geomagnetic storm, like a solar flare event, right? and that this type of electromagnetism in the atmosphere was essentially screwing up the compasses across the ONC network. It's really that cool, right? So something that's happening, um, it's like an astronomical phenomenon, but
Yeah.
we're recording it in the deepest parts of the ocean. So it's pretty neat. That we don't really quite understand the implications of that yet.
Right.
Right now, that just still stands as like a very
Yeah.
cool observation. You know, why that's important and how we can learn from that. We're still working that out, and that's part of the process, right?
Yeah, well, and I think this again, it's the power of having these instruments in the water and available, and the data available to so many people. You know, somebody picking it up that you may not know of because it's available. They ask for it, they get it, and all of a sudden they're like, well, wait a minute, let's go into this piece of data because there's some anomaly here that happens. We've talked about solar flares, we've talked about earthquakes, we've talked about landslides. You know, we've talked about the blob and anomalies in oceanographic data. You know, this data's been around for a long time. It's going to continue to be around for a long time. How often do these discoveries happen? Is it like every 5 years you're like, okay, let's take a look in the data and let's see if there's any anomalies here? Like for I guess COVID is for you, like what's the process and like how do we discover these mysterious discoveries in so much data? Is it the power of the partnerships that ONC has and the researchers that continue to look at the data?
Yeah, absolutely. It's definitely just um, working with the community, and I think it just takes a certain sense of creativity and
Mm,
thinking outside the box. I mean, you never know. I'm convinced that there's many, many, many discoveries like the ones that we've been talking about that already exist in the data and archive that we have on the on the ONC network, and so. It's just going to take that spark of inspiration or the right
yeah,
person asking the right question to say, "Hey, what if we looked at that and what do you think that means?" And that's
right.
what scientific discovery is all about, and that's why working at ONC is such a cool and special job.
Absolutely, you just never know what you're gonna get. Gwen, with working with NRCan for NRCan over these number of years, and working with ONC during those years, how important is this partnership to the government? You know, in the research that it does, and understanding this part of the coastline and this part of the ocean so much. How valuable is that for NRCan and just the government of Canada in general?
Well, back in 25 years ago, basically our institute, which is a government institute out in North Saanich, was the main institute examining these things.
Mm-hmm.
Ocean Networks Canada came along and started from almost nothing to now a very, very strong team that provides a lot of added benefit to our work. And lately, even though the focus is based around observatories, these networked observatories, Ocean Networks Canada is also reaching out to scientists to see if they can help conduct experiments that give added value to the sort of monitoring that they're doing on the experiments. And so there are a number of cases where we've said, okay, you're going out there, you're going to be maintaining these networks, and can we design this other experiment that will tell us something more about what it is our various departments are looking at. I don't want to speak on behalf of all the departments.
Of course.
Our department is responsible for looking at seabed processes, natural hazards, geological histories, geological formations, and this sort of thing. And Ocean Networks Canada has been absolutely critical on that. I think partly because of the president of Ocean Networks Canada also comes from a marine geoscience background, and so there's been a lot of emphasis on earthquake early warning and on tsunamis and on seabed pressures and on sort of these geological processes. So it's been good for our department, Natural Resources Canada.
Yeah,
Yeah,
absolutely.
just want to comment that there's a couple of layers to this. One is we've got core sensors that have been out there the whole time, and they are sort of painting the canvas of the ocean. They're showing us the background, persistent process that happen on tides every day, seasonal variations every year, and onto this canvas now, researchers can come to us, like Kohen was talking about the bottomlander. Researchers can come to us. We've got this history of how the ocean is responding in this area, and then they can plan an experiment with a lot of knowledge about what they might expect, and then they can fine tune the experiment to really look at things that you wouldn't have been able to do if you came and you didn't know what the environment you were going into. So we've got the Ocean Networks Canada provides this canvas onto which you can design really specialized and very rewarding experiments. And that canvas also includes sort of climate signals as well. So the longevity of the time series now, they're getting over 20 years. We're one of the few sites in the world where we have a long enough record to start to tease out the differences between the annual variations and the long-term trends that might be associated with climate change. So that canvas has its own layer of science as well.
Absolutely, Richard. And I'll just add one more thing in that um, ONC by maintaining and operating this network, this facility, also has the expertise of how to work in the ocean environment, right? So
Yeah.
when different scientific partners come from all around the world to leverage that set of expertise and to actually do things in the ocean environment, which is really not easy, right? And so that engineering expertise, the at-sea expertise, is really a special component of that.
Yeah,
Yeah,
that's huge. Huge point.
I'd like to emphasize that because I'm one of the scientists who's in a government organization who really leverages that sort of expertise, and so I often go across the road to Ocean Networks Canada and say, I'm thinking about this type of experiment, and that's how these things, that's how we generate the ideas for these platforms, and the engineers at Ocean Networks Canada have these capabilities that we just don't even have in house at our specific department.
Yeah, it's such a huge aspect, and to be able to get the data too. Kohen and Richard, I guess this is for both of you, because you both have like this experience in connecting with other researchers from all different backgrounds. People who are listening to this podcast are in different parts of their career. I have a lot of early career scientists and of all different backgrounds, as well as mid-career and late career, but I also have people who are just interested in the ocean in general. If a researcher or a scientist wanted to look at some of the data or get a hold of some data, where do they begin in terms of like what type of data that's available, just the catalog that's available? How can they sort of like, who do they contact? How does that work? I guess Cohen, we'll start with you.
Yeah, it's a great question, and that's what it's all about. Anybody around the world, and I mean it, can get a hold of us and ask questions, and we're here to support. And so that's um, I think for questions related to the science or hypotheses, then the science team at Ocean Networks Canada is,
Yeah.
is a great place to start, right? And we have different disciplinary experts as part of our group. If you have questions about geophysics or benthic ecology or ocean acoustics, and then we can point you in the right direction, and we just begin that dialogue. And I know there's a way to support within that. And so, yeah, just send us an email, give us a call. We'd be
Awesome.
happy to help and talk data any day of the week.
Fantastic.
The other thing Ocean Networks has done right from the very beginning, and I don't think this is necessarily unique, but we took it on very seriously, was to build a comprehensive data archive at the same time. So at the same time we were putting instruments out, we were not ignoring the back end, which is how do you deliver the data to
Yeah.
the researchers. And so we have this amazing system called Oceans 3.0, the data portal, and it has many different components to it. One of the components is the data preview. Because the data archive is so vast and huge, we're certainly up in the petabyte sort of range of environmental data, which is quite unique in the world. We have a data preview section where we plotted up a number of the core sensors, so you don't have to go in and ask, do too much sort of searching in the blind. You can just pull up plots that already exist, have a look, see the variability, maybe find the data that you're familiar with or some other data that you haven't been familiar with, but you see some interesting signals. And it gives you an idea. You can come in and look at that. It's all free. All of the data is free, both in the preview sense, and then you can go and download data. And the one of the things that breaks this barrier down is, like when I started, to be an oceanographer, you needed to live on the coast. You needed maybe to have access to ships and very expensive resources. Well, Ocean Networks Canada breaks down that barrier. We have researchers that can be completely landlocked. They don't have to access large, expensive ships. They don't have to become experts in these data systems or the instruments. They can come and they can explore the archive from anywhere with an internet connection. They can preview the data. They can then download. We actually have a plotting utility. So if you see some signal in there, you want to see if you want to, is the signal I'm interested in there? You can play around with the plots. If it's maybe there's a hint that data, the signal is in the data, then you can go and download the data and do more further analysis. And that not only includes the sensors like measuring temperature and salinity, but the hydrophone data, the camera data, the multimedia data as well. So it's all available. It's all free. There's no burden. You don't have to pay to access it.
Yeah.
And then, like Kohen says, we have the staff that if you have questions about what you're seeing, contact us, and we've got experts in-house that are familiar with that data stream. They know how to access it. They can help you get it. And like Gwyn said, and most often you end up trying to drink from a fire hose before you know it.
Amazing. Thank you so much. This has been incredible to have all three of you gentlemen on the podcast to be able to talk about these great discoveries. I can't tell you how much I want to thank you. My audience thanks you, and just the work that you've done over the years and you continue to do in the future. Thank you so much, and being able to communicate this. I hope a lot of more scientists are able to take advantage of the free data and these streams of data that come through. So thank you so much. Really appreciate you coming on the podcast.
Great to be with you.
Yeah, thanks so much for your time. It was fun.
Thank you, Richard. Thank you, Gwyn. Thank you, Kohen, for joining us on today's episode of the How to Protect the Ocean podcast. This was such a fun episode to go through. Just imagine being able to set up a platform of instruments just to know that it's going to, and hope, I guess, that it's going to get taken and go down a landslide and discover something completely new of how submarine landslides work. It is amazing to be in science. It is so wonderful to be curious. I don't think we really understand or encourage people enough, especially our kids, to be curious and to go find something that you just never expect. And it's kind of a fun thing to do, but you have to put yourself out there just like ONC does and his partners does to make new discoveries. And I think creativity, having the ocean instrumentation to be able to do that allows us to make these scientific discoveries that you've just never expected. And that's what was beautiful about this episode. So I thank Richard, I thank Kohen, I thank Gwen for joining us today. And it was such a great opportunity to speak to leaders in oceans and scientific discovery, especially with the ONC network. It is absolutely wonderful. If you have any questions or comments, just let us know in the YouTube comments below. Or if you're listening to this on your favorite audio podcast, you can go to speakupforbblue.com/feedback to let me know how you feel. You can either leave a message or a voicemail, or you can actually text it through or type it in. That's it for today's episode. Thank you for watching. This has been another episode of the How to Protect the Ocean podcast. I am your host, Andrew Lewin. Have a great day. We'll talk to you next time, and happy conservation.